Okay, hello and welcome to our penultimate lesson. It's number 8 of 9. Obviously we've combined a few, so it's not actually 8 altogether, but it's part 8 essentially of our look at energy of its key stage 4. So it's our last of 3 where we're looking at the generation of electricity. Still one more to go at the bottom here, which is going to be the use of electricity and the costs. So what we're actually going to do is have a look at some of the maths behind actually working out energy production and costs of it and things from there. So it gives us a look at our actual units, our standard units that we use inside of energy. But that's our next lesson. What we're going to look at right now is, as I said, the last type of electricity production, which is our geothermal and our solar. So, geothermal, this is a new one for key stage 4. It's not mentioned at all at key stage 3. And by the time I finish explaining it, you'll probably understand why. This is all about harnessing the heat from the earth. It's very, very similar, or has some similarities to radiation, so to do with our nuclear, because as I said, it's to do with the heat of the earth. So, geothermal, how does it work? So deep underground, in certain places there is rocks that possess this radioactive material. And as we said, there's radioactive material that we have in nuclear power plants, which is, most commonly our plutonium and our uranium. Now these rocks deep underground, they're still doing exactly the same as what they're doing in nuclear power plants. The radioactive material was decaying, and as it decays, it creates this massive amount of thermal energy. So what geothermal tries to do is harness that thermal energy and use it so we can produce electricity. Now, above the surface, the power station is actually very similar to most of the power stations we've looked at, especially the fossil fuel ones and the nuclear ones. All it is taking a hot source and using that to spin a turbine, to then spin a generator, to then create the electricity. But how is we actually getting that heat to begin with? So, as I said, under very, very certain circumstances, deep underground we'll find this rock, these rocks that have this radioactive material. Now above it, there needs to be a surface of rock of which we can actually put a body of water. So it needs to be something which is non-permeable, or impermeable rock. And again, above that, there also needs to be another section of impermeable rock. So in the middle, we can put our reservoir of water. Now there may already be water there, but what's actually going to happen is obviously because it's capped between these two rocks, the heat that the water is producing, or the steam that's being created from this thermal energy from our decaying rocks, it's got nowhere to go. So what our geothermal power plant does is it bores 2 holes, it drills 2 big holes into this reservoir. Now one of them is pumping cold water in to be heated up by convection, don't forget our convection currents. And again, the other pipe is actually letting the hot steam or the hot water come out of our reservoir, and which is going to be used as our kinetic to spin our turbine. Now that's the basics behind it. So it's decaying rocks, or the decaying radioactive material in rocks, only in certain places, that the heat is used to heat this water body, which could either be naturally there or artificially put there, as long as it's capped between these 2 rocks. And then we're pumping cold water in for it to be heated and then be extracted out, the hot water, or the steam, to spin our turbine to create our electricity. Now that's the basics behind geothermal. Now it sounds brilliant, because at the end of the day all we're doing is actually taking heat from the earth. But the very idea of that is why it's really, really, really rare. Brilliant, it's renewable. Again, brilliant, it's a really reliable source. This radioactivity in the rocks is not going to run out in any time soon. It's going to go on for thousands of years. There's no fuel costs and there's no pollution. Those 4 things are brilliant. That's exactly what we want and our advantages. But what's our disadvantages? It's expensive to make, but the most and the biggest disadvantage to it is there's very, very, very few places in the world where these conditions actually exist that we can take advantage of it. Most notably, you'll find them in Iceland. There is one in California, but they're very, very, very rare, which is why they're not very used at all. They're not used at all, really, because it's just the conditions that you need to create the electricity are just not there. But again, it'd be rude not to have it. It is renewable, it's good, it's clean, it's good, clean power, but it's very, very specific, even more specific than where we could put any of our other renewable energy sources. So that was our look at geothermal. Now, solar power. Now, there's two types of solar power. We introduced this at Key Stage 3. There's the solar cells and there's solar panels. So you should remember most of this from Key Stage 3. Our solar cells actually directly convert light energy from the sun into electricity. They're amazing, amazing little things. They could be that big, they could be that big. You'll find them, most commonly, you'll probably see, would have seen them, are in calculators. It's that little panel on the top of the calculator. It's just running from solar energy, from light. It just directly converts light into electricity. They're amazing. They're amazing, amazing little inventions. What's our other one? Our other one is solar panel. Now this is actually completely different. This is actually nothing to do with electricity. This is all about heating water. So what we have here is our solar panel up in our top left corner, and this is attracting the light and the thermal radiation from the sun. Now there's a pump here, it's a system of cold water going up and running behind our solar panel. As that thermal energy hits our solar panel, it's transferred into the water and heats our water up. As that water moves round, again from convection, the hot water can be used. Now this is predominantly found on roofs of houses or of buildings. Now this again can be used to heat bodies of water, so it can be used, for water in your house, to make it, to run a bath or anything like that. Any general water purposes for your household. So these are the two main things for solar. So what are the good things? Again, always the advantages. They're renewable, it's a reliable source, and there's no fuel costs, okay? But the reliable source is only the fact that it's light, so in the daytime it's good. So what's the disadvantages? Well, effectively, especially the solar cells, they're quite expensive to make. They're very inefficient, they're not very good at actually converting the light into electricity. With our solar panel, the inefficiency of transferring that heat to the water means that it would actually probably need to be run alongside a conventional boiler in your house anyway. So you would need it, but you would also need something else to back it up. And also the big thing is, including the name, it's solar, so it relies heavily on obviously there being sun. So even in hot countries, the inefficiency of it transferring that heat and that light energy into useful energy, even in really, really hot countries, sometimes that's not enough. So in normal countries, so in England where we have cloud most of the time of the year, it's not that good. And more especially at night, there's no sun. So there's no electricity, there's no hot water being created. But it is renewable. So in hot climates, it is a good alternative. But for in other countries, is it a good alternative? I don't know. So that was our overview. Our overview is obviously having a look at geothermal energy, the very specifics of it. Again, it's a really good energy source, but the conditions of what you need, it's very rare for it to happen. And solar, which is good for very hot climates, but its inefficiency doesn't necessarily make it a good source for other places around the world. Now that was part 8. Our final part, we're going to be looking at the uses of electricity and the costs of electricity, and we're also going to be having a look at the units of energy as well. So yeah, thank you very much.